I replaced my sister's drain hose on her machine with something I already had, so it's not really what I was thinking of. I was thinking of one of the ones with the internal spring thing to keep it from collapsing, but this is a much stiffer hose, and she's going to use it right away before I change out the valve or do anything. So we don't have a rubber stopper right now, but I have Instamorph. Instamorph, if you've never seen that, it's just a plasticky stuff that comes in beads, and you warm it up with warm water, and then you can mold it and play with it. And as long as it's pretty warm, it stays pretty malleable. So we're going to use that and just cram it on there to make a stopper. So hopefully some of it's going on the inside of the hose also. And we'll just let that cool, and that will be the stopper for now. If you compare this original hose, see, I can just squish that right down. And this one, it's very, very stiff by comparison. So we'll give that a whirl. Worst case is, if this plastic stuff sticks to that, we can just cut it off or put it back in hot water and it will get soft again, and then we can remove it. I'm back over at my sister's place to kind of check on the drain valve thing. And while I was here, I was looking at the thermometer she has in the trays. This is a good example of when I talk about the machine is easy to fool, and so don't trust the machine. This is a good example. She has 4 trays in there. 2 of them are frozen corn. They were frozen corn. Now it's going to be freeze-dried corn. And 2 of them are shredded cheese. The machine says that it's supposed to be done in about an hour, and I added additional time so that it wouldn't be done yet, because it's not going to be done yet. The 2 trays of cheese both say about 100 degrees. The bottom one says about 110. The next one says about 100 degrees. Both of the corns are about 0. There is no chance that they're done freeze drying yet. There's just no chance. But the machine thinks it is, because it's not sublimating enough moisture right now to raise that pressure for its sensors to know that it's not done. And part of that's because she has 2 trays that probably are done, and then because of the thicker layers of corn, the middle might not be done, but the 2 outside edges are done, the outside layers are done, and so it's slowed down on how fast it's freeze drying. Yeah, so it's easy to fool because it has no idea how we've loaded it. If you always loaded it the exact same way with the exact same product, then yes, it would be easy to set up a sensing system to know if it's done. Commercial companies would do something more like that, because they would have a set program for a set load. We're using an average kind of thing, so it's going to be less likely that it's going to be right each time. Anyway, just wanted to point that out, and then we'll show her drain valve piece. Now, I think that her valve did leak more. I'm pretty sure that this is squishier than it should be. And one of the things that we can do to test that would be to open that valve. With the plug on there, if that valve has not leaked and this hose is still full of air, when I open that valve, the pressure will shoot up. We can watch for that. Right now it's saying that her pressure is at 231. So it's showing 230 right now. And I'm just going to crack that valve open a little bit and see what happens. Okay, went off. So I opened it and closed it. And let's zoom in on that. So I'm going to open it again. So right now the valve is completely open. Okay, so you can see the valve is in the open position. The pressure didn't move. So the valve is not currently holding full pressure, but it's so good that it was enough to get the vacuum and to function and it to think that it's good. I was going to show the other piece, and I'll have to show that later. I want to show how much I can show that on mine later. So I'll show that later on my machine, how much pressure change you get just with the hose full of air. If you block the bottom of the hose, and so you have just that amount of air, turn the valve on and turn it back off, it allows that amount of air to go rushing into there, and you'll see how much it changes. It's quite impressive. Okay, we'll do that before we do the dry check on my batch. I wanted to show one other little thing. I've mentioned before about how little of an air leak it needs to make a big difference, so I want to do a little demonstration. The vacuum pressure says 168 right now. So what we're going to do is let a teeny bit of air in, kind of a measured amount. So we'll show this. So here's my drain hose. So this is about 75 centimeters long from the valve body or from the valve core to the end. And it's a little less than 1 centimeter in diameter on the inside. So it's less than 60 cubic centimeters of air. A very small amount considering the size of that chamber. So I'll move the camera so you can see the pressure change, and then I'll turn the valve. I'll put my thumb on the end of the hose. Now I'm going to turn it to open, and then I'm closing it. Okay, it's already closed. And it takes a bit of time for that pressure to distribute around inside there. And we'll see how high it goes. And again, it's already closed. It's been closed this whole time, well, except for that second when I turned it on and off. Okay, so it made it almost up to 2100 before it started dropping back down. So as you can see, it doesn't take very much air to make a huge difference in here. So if that had a very, very small leak and it was continuous, it would have a really hard time to get down. And we know from experience that a single hair across that seal is enough to make it have a hard time or even to fail. It really is important to make sure every single spot is checked. I also want to mention the little measurement we did of the hose and the volume. That would be a little bit bigger. The amount of air that that hose holds would be a little bit bigger than these 2 pads of Post-it notes. So that whole chamber, that amount of air added to it, bumped it up to about 2100 millitorr. It doesn't take much of a leak to be a problem. So it's been a few more hours since I was over at my sister's, and this hose has maybe collapsed a little bit more, but as we already saw from the valve, we can open the valve and it doesn't change anything on the pressure. This is holding the vacuum, the valve isn't. The question is how much air is going through the valve and how much would it affect the pressure reading. It's holding steady at 217, and when we checked earlier I think it was 230 or 231, so it hasn't moved much in hours. But what we want to do now is find out what would happen if we take this plug out. How much air is going through that valve, and would it make a noticeable difference on the pressure readout? So let's give that a try. And I've got a little container or a gallon jug of some water with a little bit of blue food coloring so we can see it go up if it does. Though it isn't a lot of volume. As we showed you before, a couple of stacks of Post-it notes is the volume of air in this hose. And you compare that to this chamber, that's an incredibly small amount of air. So we'll get that off of there, hopefully, and we'll test it. I don't know if this kind of plastic sticks to this kind of plastic. Yeah, we might have to cut it off of there, which would be a problem because then we wouldn't be able to get it back on there. But we could clamp it because the rest of the hose probably isn't going to collapse. Or we could ignore it if it's small enough of a leak. Oh, I could heat it up. That's what I need. I need a a container of hot water, because this plastic, you get it fairly warm and it gets soft. Okay, I have to get some hot water. Don't go away. Let's see if that's enough hot water to soften that. Come on, don't stick to there. Well, that's still very hot. Yep, warmed up the hose and it collapsed it. I was afraid of that, but let's get this off of there. Okay. Sheesh. Wow, that sealed it extremely well. So now we're going to put that in the jug of liquid. Oh, I was going to look at that. 216. No big difference. There we go. Checking this. Oh, 254, 255, 257. Is the heater on also? No, the heater is not on. 261, 262. Okay. So while that's doing its thing, I don't know how much it's pulling up. Let's try to make sure we don't pull it out of the water. 275. Oh, there's the water level right there, I think. Okay, the water level's about 3 inches up so far. And that little teeny bit, each centimeter this way would be about 3/4 of a centimeter, or 3/4 of a cubic centimeter of air going in. And that's been enough to raise it. Now it's 283. So now 284. So it was, what was it, 212? I don't remember what the number was. Now 292. So we should get to a point where what's coming in and being pumped out can equalize at some higher pressure. 295, but it's certainly not going to be where it was. There it is, right there. So about 5 inches, 6 inches, probably about 6 inches. There, you can see the water level bouncing around. No, that's not. Okay, now it's up here. Okay, there it goes some more. So you can see the previous line was down there. Yeah, that's got a pretty good view of it right there. And what's the pressure now? 304. Yeah, I'll try white behind there. See what that does. If I had it for a second. Every so often I see a glimpse of it. So there it is again, right there. Yeah, at this pace, in 10 minutes or 15 minutes, it's going to be at the valve. So it's been a few minutes, as you can see, and it's at 302, 301, fluctuating depending on how fast it can pull it back out. So I'll see how long that was. So it's been about 12 or 13 minutes now since I put this in there, and it's gone a little bit more than a foot, roughly 1 inch per minute, so 2.5 centimeters per minute, somewhere in that range. We have added more dry time because the corn still isn't close to done. This tray, in tray 2 position, which tends to be warmer than the top one or the bottom one, It is almost to 60, but the top one's still only about 25. There's not a chance that it's done, so we're just adding time. She'll check it tomorrow.